Okay, peeps, this is the last balancing equations practice sheet. This is page 10 in the chemical reactions packet. And notice this one says it's wicked hard. For those of you who don't know, Mrs. Martioski is from Massachusetts. And so that's what they say, wicked. It's wicked hard. You guys know my daughter lives in Boston, so. Okay. All right, so this one is hard because oxygen, it's in two different places here. Again, this water is going to drive the issue here. It can't be odd because they have to be even on this side. So I'm just going to, I can see the chlorines are not balanced. The lead is balanced. I'm just going to jump in and put a 2 there and see what that does for me. That gives me 4 oxygens on this side. 2 here and 2 more there, so 4. If I put a 2 here, so that I have 4 oxygens, that gives me 2 leads. If I put a 2 here to balance my leads, that gives me 4 chlorines. Notice you kind of just keep going back and forth, see if you can get it to work. 4 chlorines, this would need a 4. What does that do to my hydrogens? Yeah, that works. Hydrogens 4 now, and the hydrogens are 4 over here. So, and again, when you do a hard one, check it. 2 leads, 4 oxygens, 2, 4 oxygens, 4 hydrogens, 4 hydrogens, 4 chlorines, 2 times 2, 4 chlorines. Okay. All right, number 2. Number 2's got a problem. This is lead, but this is phosphorus. So, all right, something's wrong here. Skip that one. All right, number 3. Let's see, if we look at this, this is a similar problem as the water being odd. We can't have this oxygen be odd because of this oxygen's always going to be even. So what if I just put this 2 here to make it even? So that's now 2 oxygens. Look what that does to the copper. It gives me 4 coppers. 2 times 2. So I'm gonna, if I put a 2 here to have 4 coppers on this side, that gives me 2 sulfurs. If I put a 2 here to balance my sulfurs, now let's see what the oxygen situation is. 2 times 2 is 4. 2 here, so 6 total on this side. So I can put a 3 here to get 6 on this side. Okay. All right, number 4. If you look at this, similar issue here. This is an odd number of oxygens right here, and it can't stay as odd. This can't be a 1 or a 3 or a 5. We can't have an odd number of oxygens over here. So I'm gonna see what happens if I make it even. And usually you just start with the lowest number. These coefficients usually don't get very high. So that would give me 6 oxygens on this side and 4 irons. Well, let's see, if I put 4 irons here, that's 4 irons and 4 sulfurs, so I'd need a 4 here to balance the sulfurs. And that gives me 8 oxygens. So my total oxygens over here are 14 now, which means this needs to be 7. Okay. All right, number 5, we've done one like this. Get these oxygens up to 6, least common multiplier or something like that. So if I put a 2 here, so that's 6, and a 3 here, so that's 6. Then the irons are now 4. Number 6, let's see, the sulfates are already balanced, and but the nitrates are not. I have 2 nitrates over here, but only 1 here, so I'm going to need a 2 here. And what does that do? That fixes the hydrogens. Calcium's already balanced. All right, that's balanced. That's all that took. Okay. All right, let's see. This is a polyatomic ion we haven't used yet in balancing equations. So that's chromate. So there's 3 chromates on this side, but only 1 on this side. So if I put a 3 here, that jumps my sodiums up to 6. So I'll put a 6 here, which jumps my chlorines up to 6 also. So to balance it, I'd need a 2 here to get the chlorines to be 6 on this side. And that gives me 2 aluminums, which is what I need. So that's good. All right, next one, there's chromate again. This time they're showing you them as ions. You ignore that charge. They're probably like floating around in water, and so they're ions. But if they bump into each other, they'll form this. They'll form aluminum chromate. Okay, so let's see. There's 3 chromites on this side, so let me give myself 3. And 2 aluminums on this side, so 2 on this side. So that's it. That was easy. All right, this one. This is another issue with that even-odd issue that you can't. Or actually, this isn't so much even-odd. This is 2 and 5 are never going to equal each other unless you take them both up to 10. So if I put a 2 here, that'll give me 10 oxygens. And if I put a 5 here... Oh, wait a minute. I'm not paying attention to these ones. Hang on. I don't want a 5 there. Okay, 10 oxygens. Let me ignore my oxygens for a minute. Let me do the nitrogens. So 2 times 2 is 4, so I need a 4 here. All right, now let me look at the oxygens. So 4 times 2 is 8, and 2 here. Okay, so that's 10. So this needs no coefficient. All right, this last one you can see because of our picture, the copper sulfate got jumped down there. Just let's bring it up here to make it easier to look at. All right, so let's see. Again, the polyatomic ions stay together, so we can look at it as one unit. So there's 3 sulfates here and only 1 sulfate here. Remember, SO4 is a polyatomic ion called sulfate. It has a -2 charge. And OH is hydroxide, another polyatomic ion. So 3 sulfates here. I need 3 on this side. That gives me 3 coppers, so I need 3 on this side. That gives me 6 hydroxides, and to get 6 hydroxides on this side, I'll need a 2. So 6 hydroxides on this side. And that 2 gave me 2 aluminums, so I'm good. So that's done. That wasn't too wicked hard. All right.